Okay, everybody, I'm going to go ahead and get started, even though it's not technically 10:35 quite yet. My name is Cassandra. Most of you who have spent time in the department probably know me a little bit better as Kay. And I would like to welcome everybody to one of our two DNA classes we have here at the East Baton Rouge Parish Library. We have this one, and then we have one that is also a little bit more complicated. And we are not going to go into the deep science of how DNA testing is done as much today because there's just not enough time to go into everything. As I said when we started, I am going to open the floor for questions, but we're going to do those at the very end because there's another program immediately following the one that we're doing right now. And I don't know that we'll have enough time if we have to stop for questions throughout for everybody to get through the end. So come on. Flip over. There we go. So here's our title slide. This class is DNA testing and results, as I said. So what we're going to cover today is a brief synopsis of DNA and how it works. We're going to go quickly into DNA recombination, sequencing, and inheritance. We're going to briefly cover haplogroups and haplotypes, some terminology that you will see with your DNA results and the different tests that are available today, what to expect from those results. We're going to cover Y DNA tests and mitochondrial DNA tests, as well as autosomal. Some common questions regarding genealogical DNA, how to find the best test to meet your individual needs, and what to do with your DNA once you've got it. And I know that sounds like a whole lot, but really it's only three basic parts of the program. We're going to cover DNA itself, testing and results, and then what those results mean and where to go next. So the most basic question then is, what is DNA? And I apologize for our in-person people. This slide does not look this dark on my screen. I don't know why it doesn't show up particularly well, but the others are better. So DNA is deoxyribonucleic acid, or the building blocks of life. Some of us may remember this from the 1993 hit movie Jurassic Park. There's a really famous cartoon sequence in there where Hammond is giving the first tour, and he talks about the way that they extracted the dinosaur DNA from the amber. And while all of that is pretty sci-fi, the actual building of a DNA sequence is pretty complete, even today, even 25 years later. And actually, these notes are a little old, so let's all just take a moment to realize that 1993 was actually closer to 30 years ago. It gets its name from the sugar deoxyribose that builds the backbone of the double helix that we know so well. The rungs of that ladder are 4 kinds of nucleotides that pair together to make up the unique sequence that is your DNA. Adenine and thymine, cytosine and guanine. And adenine pairs with thymine, and cytosine pairs up with guanine. Specific mutations along these base pairs that are present in 1% or more of the population are called single nucleotide polymorphisms, SNPs, or better known in biology as SNPs. And these are going to be very important later. And fun fact, humans have about 3 billion, that's with a B, base pairs of DNA over 23 chromosomes. So this leads nicely into what is a chromosome. Y'all see what I did there? Human beings have on average 23 chromosomes. 22 of these are autosomes, which carry the basic information about your genes. That includes things like your hair color, your eye color, your skin color, body type, identifying characteristics, so on and so forth. The 23rd pair, obviously, is your sex chromosome. XX is female DNA, XY is male DNA. So if each parent has 23 chromosomes and each child has 23 chromosomes, how do we work out that math? That's where the process of meiosis comes in. This is where the chromosomes split, duplicate, and then recombine to create 23 or so new pairs for a whole new tiny human. And another fun fact for that, DNA randomly recombines, but sometimes it simply replicates itself instead. So you might actually have more DNA in common with one parent than you normally would. And DNA inheritance. So you get about 50% of your DNA from your father and 50% from your mother. This is pretty much what you would expect. Each of your parents obviously also would have received 50% of their parents' DNA. So the math would logically lead you to conclude you'd receive about 25% from each grandparent, 12 or 13 from each great-grandparent, so on and so forth. But that's not quite how it works. when you receive 50% of your parents' DNA, there is no way to know which 50% you're going to inherit. You could inherit 5% of your grandfather and 95% of your grandmother DNA, so on and so forth. I'm going to show you an example of this, and I want to stress to everybody right off the bat, this is an extreme example. In the real world, recombination is probably not going to look quite like this. It's not going to be this extreme, but I want to show you how you can have such staggeringly different results from a sibling that you might not have expected to get. So here we have 3 separate generations. Ignore my stretched out and chunky little infographic here. But you can see here from the recombination of each successive generation, how much this DNA can actually change. This includes 7 different regions. Up here on our upper left, we have who would be considered the paternal grandfather in this scenario, and he has 3 different regions: Central and Northern Asia, Japan, and the Philippines. Mom here is 100% Scotch-Irish. Almost nobody these days is going to be completely 100% anything. The world is too mobile today, and as DNA science advances, it's pretty uncommon to find people who are 100% of anything. But just for the example that we're doing here, this makes it a little bit easier. Mom over here on the right has 2 parents who are, our father is 100% from the Ivory Coast in Ghana. Mom is 50% Iran and 50% of the Middle East. So we have, and the Middle East is a large region that covers several different countries. So you can see just from one generation to the next, both of these inherited about 50% of their dominant parents' DNA, which you would expect. No matter which 50% you're going to get, it's probably going to be from either the Ivory Coast in her case or Ireland and Scotland in his case. But the second part of the DNA is a little more interesting. You can see he inherited about 25% of the Central and North Asia and 25% of the Philippines. So just in one generation, 1/3 of Grandpa's Japan DNA dropped off, which obviously means the grandchildren are not likely to inherit that. And then same thing for Mom. She inherited 40% of her mother's 50% Middle Eastern DNA, but only 10 of the Iran. So by the time you get down to our children, we have 3 very, very different DNA profiles. Again, this is a really extreme example. You're not likely to find one child that has 5 different geographical locations spread over their DNA, and another that has really only 2 and kind of a slice of 1/3. But it can. So this is why when you take a DNA test with a sibling, your DNA might come back 10% Italy, and your siblings might come back, 25% Italy. Even though you have the exact same parents, you inherited different DNA sequences from your parents. So criminal DNA is all about finding the 1% of you that makes you different from everybody else in the entire world. The thing that can make you the only person that was at a specific place at a specific point in time to commit that crime. Genealogical DNA is the opposite. It's all about finding what is in your DNA that makes you part of a larger group. Short repeating patterns at different rungs on the ladders are called short tandem repeats. These are these genetically similar strands that are carried down from generation to generation in the same or similar regions. Looking for these specific repetitions at points in predictable patterns along your DNA strand ties you to others. More repeating patterns mean a stronger connection to a particular region. These sequences, as I said, in particular and predictable order, help tie you to larger groups, which are then assigned to even larger ones. Haplogroups and haplotypes. We're moving right along into this section. A group of haplotypes that share an ancestor with a distinct single nucleotide polymorphism, that's that mutated rung on the DNA ladder, is a haplogroup. Haplotypes are smaller and more distinctive groups sharing alleles or SNPs within their group. So we're going to look at the human genome kind of like a tree. We all know what a gene is. Most people understand what you say when something is in your genes. Alleles are variant forms of genes. Usually, as we said at the beginning with our autosomes, alleles are the ones that often carry your recessive and dominant traits. Think of humanity kind of like a tree. As I said, the trunk would be humanity. That's the genome to which we all belong, no matter our sex, our race, our age, whatever. We're all human beings. The haplogroups are like the large limbs that branch off of that tree. They spread out into different directions, but they're all connected to that same base. Haplotypes are the smaller branches that then branch further off of those trees. Just because you belong to a particular haplogroup does not mean that you will belong to a haplotype within that group. Another fun fact, there are 20 or so main Y haplogroups. There are about 4,000 mitochondrial haplogroups. So why are we talking about this? This is going to move us into some terms to expect with your DNA. And then we're going to talk about the different kinds of tests. And those tests, that's why these things are important. The way that those tests test for whatever it is you're looking for in your DNA, whether it's regions, your haplogroup, whatever, will determine the results that you're going to get. So a region is pretty self-explanatory. It's an area that can include one or more modern day countries. Regions are not bounded specifically by country borders. Ranges are the variable to calculate the amount of DNA that you carry from a particular region. Matches, again, are fairly explanatory. A person with whom you share a specific amount of DNA. Mitochondrial DNA is a particular segment of DNA that you receive only from the X chromosome that you inherit from your mother. Y DNA is a particular mutation on the Y chromosome inherited from your father, which is used to determine your haplogroup or haplotype. And so that moves us smoothly into our tests. And you guys, there are so many tests on the market today. It has gone from just one or two in the early 2000s to over 100 that I could find just doing a basic Google search. I'm sure there are even more out there. For the purposes of this class and due to our time constraints, we're only going to cover the 5 biggest and most well-known ones that are on the market. These are going to be Ancestry, 23andMe, MyHeritage, Family Tree, and Living DNA. But we're also going to mention a couple of others that are more specific. So if you're looking to test for something that you aren't sure how to test for, we're going to cover a little bit of that. And then with a bit of searching of your own, as you get more familiar with the different kinds of tests that are available, you'll be able to narrow down your results and find the one that's right for you. If you've already taken your test, this section is not going to be quite as helpful for you as some of the others, but it will help you gain a better understanding of how you got your results or why you didn't get the results that you thought you might. So we talked just a moment ago about haplogroups and haplotypes. These are determined by your Y and your mitochondrial DNA tests. You get one of each from your parents. The Y DNA tests are just what they sound like. They will only test your patrilineal line, and they are tested differently than mitochondrial DNA tests. They are determined by short tandem repeats and confirmed by further SNP testing. While mitochondrial DNA tests are exactly what they sound like as well. They only test your matrilineal line. These can go back hundreds or even thousands of years, depending on which haplogroup you belong to. Also are determined by SNPs. They're determined by one particular region on your X chromosome inherited from your mother that does not mutate. One of the very few parts of your DNA that does not change and recombine during meiosis. So that's why it's so easy to tie you that far back. This one does not change from generation to generation like most of them do. Okay, so this will show you some of the problems you're going to run into with choosing to take these kinds of tests. Obviously, I used my brother's initials here because clearly I'm biologically female and can't take this test. But you can see this leads from one to his father, to his father, to his father. Same with your mitochondrial. From me to my mother, to my grandmother, to my great-grandmother. And it's never going to fill in some of these boxes in the middle. Even if you are a guy and you can take both, you're still going to be missing all this stuff in the middle. And even if you can find, a grandmother or somebody who can take one for her side of the line, you're still just going to keep going. It's just going to keep branching back, and you're not going to be able to fill in those center spots. The pros with this are that they are much more accurate than an autosomal DNA test. They can pinpoint you to a particular haplogroup. They are much more comprehensive picture of your genealogical history, and they go back hundreds, as I said, or even thousands of years. The cons with these are that they are a lot more expensive. And they do not, obviously, as I said, fill in your whole tree. They also don't show where your family has traveled since point A. So if your family is initially from a particular region, it doesn't show their history since that point in their movements. The much more common and familiar one to most of us, these are the ones that you see the Ancestry ads for, or you see your 23andMe pop up on your Facebook advertisements or whatever, is your autosomal DNA test. And it does exactly what it sounds like. It's going to test your autosomes, and it's going to fill in most, if not all, of your most recent family history. They're much more common. They're a lot easier to get. They're more comprehensive in, like I said, as far as filling in this center part that you would not otherwise be able to find. They are cheaper. They are significantly cheaper. The cons are that they only go back about 5 to 7 generations. So because your autosomes do recombine, see, there's a reason I tell you all these things. Because your autosomes do recombine so much with each successive generation, as you go down the line, more and more of it continues to drop off. So by the time you get to you, some of these people that are 5 generations back or so will no longer show up in your genetic DNA. The cons, and then they are less accurate, again, because of the recombination and because it's still kind of in its infancy. Genetic DNA testing at home really only started taking off. The first tests were in 2000, and it's really only started taking off in the last decade or so, which sounds like a lot of time, but when you consider science itself, it's still kind of in its infancy. So there's a lot more room for error. You kind of want to think of a DNA test like an outline. Just because somebody does not show up on your genetic DNA test does not make them less a part of who you are. And just because you didn't get as much from a person that as you expected to receive doesn't make you less a part of whichever place that person came from. 5 generations, you're looking at about 30 separate DNA profiles that went into making you. So that's as far back as your great-great-grandparents. In 7 generations, that number comes up to 126. So now you're looking at your great-great-great-great-grandparents. So you can see why with recombination, by the time you get 7 generations back, you've got 126 different DNA profiles in yours. And that's why so much can often be missing. So now we want to do a quick comparison of the big 5 DNA tests that are on the market today. It's okay. Happens to the best of us. Each test has its positives and its negatives. You can see here that Ancestry and MyHeritage do not offer mitochondrial or Y-DNA tests. Family Tree does, but you have to opt into these tests, and you usually have to pay a separate fee for them. So one of the things that you really want to look into when you're trying to decide which DNA test is right for you is reading all the fine print. What comes with my DNA test? Do I get my matches? Do I get a mitochondrial test with it? Do I get, what am I getting when I sign up for this? Ancestry also does not, we talked about this at the beginning of class, does not have health tests. And you see a little question mark here. It does now, but it has been kind of a rocky road to get Ancestry to the point where they can give health screenings on your DNA test. They rolled it out, then they had to take it back. There's still a little bit of controversy. If health screenings are something that you're really interested in, 23andMe is a lot better known for that. However, you want to look down here and notice the numbers of how many people have taken these tests. Living DNA does not offer this information. Living DNA is probably the #1 that you want to go to if you're concerned about privacy, because they are very, very strict with what they can and cannot do with your DNA. So that's why this one says no info, even though we know it's one of the bigger ones that people use. So 23andMe, and these numbers are a little bit outdated, but not that outdated. So theirs are at about 1 million, whereas the sample number for Ancestry is about 15 million. So if you are a person who was adopted, or you are a person who does not know anything about your biological family for whatever reason, a sample size of 15 million is going to give you a lot more directions to look in for matches, for family history, that kind of thing. So these are all things that you want to take into consideration. At the end of the day, the thing that you want to ask yourself the most about your comparison, about your DNA test is, what do you want to learn? What is it that you really want to get answers for? DNA tests can test for all kinds of things now. African ancestry is one of the most popular ones for people who are looking to trace their families back past, for instance, slavery or whatever, all the way back to their roots. And that is a company that is run by Black doctors and Black scientists. It has a sample size of over 300,000 DNA profiles. It's a really wonderful company. The negatives with that one is that it's also very, very expensive. They started about, because they're both mitochondrial and Y DNA tests, it starts at about $299. And it also is the only ones that they offer at the moment, at least the last time I checked, was the mitochondrial and the Y DNA tests. So they don't have an autosomal that specifically focuses, that company at least, on African ancestry. If you want to know where your family has been since then or in the last few, and you're more interested in looking into an autosomal DNA test for African American people, or specifically both Black and Indigenous people of color, we recommend Ancestry for that because they have more regions than any of these other ones. And they have about 108 regions now that focus specifically more on African ancestry, both people in Africa and African American people. 96 of those are dedicated to helping African American, specifically people, trace their history, their roots through the Americas since arriving here. So they have, please forgive me, I'm trying to kick this little cold thing. They specifically have subgroups here in America that are dedicated to different regions, helping people figure out where their family would have been brought when they were brought to the Americas and where they've gone since then. For family tree DNA, as I said, or living DNA, I'm sorry, they have the best privacy rules. So they're the ones you might want to go with if you're more concerned about privacy. There's Viome and Let's Get Checked. We were kind of talking about that briefly before class. Those are tests that you take, get your results, and then you take them to your doctor. So if health results are something that's really important to you, those are the ones that specifically focus on health. There's Origin for weight loss. There's all kinds of things. So yes, ma'am. Viome, Viome, and Let's Get Checked are the two for health. And then Origin for weight loss. There's DNA tests for everything out there right now. So again, at the end of the day, you got to ask yourself, what is it specifically that I want to learn about my DNA? These are some of the FAQs that we get the most commonly across our desk when we're doing DNA in genealogy. The number one is undoubtedly, I know that my family is from, insert your specific country here. Why doesn't it show up on my DNA test? There are a lot of reasons for this. The number one is that DNA is, as I said, still kind of in its infancy. There's no way to 100% pinpoint anybody for absolute certainty to a place yet. Since taking my test in 2019, my results have been updated several times, and my background has shifted several times. Yes. Yes, if you opt in. Yes. Yes, after you get your initial results, as long as you give them permission to continue to test your DNA, they will automatically update it. No, you do not have to pay for it, at least with Ancestry. Again, that's something that you want to check into with whichever test you opt to take. You want to make sure that you read all your fine print, because some will do that, some will not. Some will give you your matches for free, some will not. You have to kind of do your deep digging into making sure that this is the right one for you. You also want to remember too that boundaries change a lot. So because your grandmother told you that her grandmother told her that her mom was from Germany or whatever, you have to think back how many generations ago that was, and then compare it to the way that, for instance, the United States looked in 1821 versus the way that it looks today. All of the boundaries of most of the countries are very similar to that. They flex and change with time. And also remember that ancestors may not have been 100% whatever region they were ascribed to either. I have a great grandmother, for instance, whose last name was Jeanneret, which would lead you to believe that she was incredibly French. However, her mother's side of the family was Scottish, and her father is half Swiss. So really, she would have only been about 25% French herself. By the time you get all the way down to me as her great-granddaughter, there's only about 2% of that French left. So just because you had a grandparent who was French does not necessarily mean that that grandparent was 100% French. Will my DNA show that I'm related to insert favorite celebrity, monarch, historical figure, whatever here? No. I mean, the long and short of it is no. Even if we had DNA profiles for Benjamin Franklin or King Louis XVI or whoever, they wouldn't do a comparison for every DNA that comes across the table to see if you were related to that person. As for, you know, regular pop culture icons or celebrities of our day, unless like Barack Obama or Britney Spears has taken one of these tests and put it out there, and I don't believe that either of them has, it's not going to show up in your DNA that you're related to that person. Again, that's why we consider your DNA test to be your outline. It gives you a place to start. It gives you somewhere to get moving, but it's not going to give you all the answers you're looking for. What are things like second cousins, third cousins once removed, etc.? We're going to get into this a little bit better in a minute so that you can understand your matches a little bit better. But the rule of thumb that I want everybody to keep in mind is that distance goes out and away along your same generational line. Removed goes up and down to different generations. What does 99.9% accurate mean in terms of results? And if it's 99.9% accurate, why do you need to update it, right? We call this a good old-fashioned half-truth. They're not intentionally wrong, but they're not intentionally right either. So as in the case of, we're going to take African history test results as an example of this. A few years ago, when they were just starting out, there were only 2 regions in Africa. There was Northern Africa and there was Sub-Saharan Africa. So if your DNA test results came back and said that your family was Sub-Saharan African, it's not technically wrong, except that, you know, you're looking at an entire continent. So that doesn't really help you answer the question of where your family came from. So this is what we mean when we say it's 99% accurate. They're saying, well, it's still not wrong though. Again, another good example is Indigenous American peoples, which until the last update at the end of 2019 was one region that covered the top of Canada all the way down to the tip of Chile. So you're talking 2 entire continents. If your DNA came back as Indigenous American peoples, you could have been anywhere from an Alaskan native person all the way down to the tip of Chile. And there was no way to know. Now with that last update, that one has been broken up into 8 regions. But even so, oh wait, I can show you. I got so busy talking. Even so, you can see if your family lies somewhere in here, it's not gonna tell you very much about, I mean, that's almost all of inhabitable Canada, almost all of the United States, and a lot of these islands down here. It's not gonna tell you a whole lot about where you came from. And the last question is going to be, what do I do if my second to last question, my apologies. What do I do if I feel like my DNA tests are wrong? First of all, one of the big concerns that we get a lot of is, and we were just talking about this before class as well too, Ancestry and other big DNA companies are under incredibly strict federal regulations as to what they are allowed to do with your DNA when it's in their hands, i.e. testing it, making sure they keep track of it, making sure it gets back to the correct person, because you are dealing with somebody's actual DNA sample. So they're under very strict regulations to make sure that your DNA gets back to you. And for like Ancestry, for instance, that accuracy is 99.99999. That's with 5 nines, accurate in getting back to you. It has happened. I did do some Googling and found like 1 or 2 stories where somebody got the wrong DNA results back. But out of 16 million, I was only able to find a couple. So it's pretty sure that the DNA that came back to you is most likely yours. What they can do with it once they've processed it is a little more of a gray area. So again, reading your privacy policies and what you're consenting to with your DNA is very important, no matter which test you take. But mostly you kind of want to ask yourself, okay, if I feel like my DNA tests or results are wrong, what is it that you feel like is wrong specifically with them? And there are some things that you can kind of look at to answer these questions. Do you feel like you have a region that's not represented as strongly or more strongly than you expected it to be? or you don't have a region that you expected to have it all, so on and so forth. And one of the things that you need to check with that is to read all of your available information carefully. For instance, I know I have a couple of ancestors that are from the Netherlands, but that doesn't show up as a region in my DNA. It's looped into the other regions that surround it, Germany as one, and England, Wales, and Northwestern Europe as the other, crosses over that cusp of the European continent. So I may actually be less English and German and more Netherlands than I look initially. So you want to make sure that you read everything that you receive so you can see where you're missing those pieces and go, oh, okay, that's where that went. And again, we want to look at this map and see this. There's also tons of places on this map that don't have testable DNA yet. And there are, I mean, tons of them: Chile, Guatemala, Belize, Niger, Chad, Sudan, the Central African Republic, Uzbekistan, Kazakhstan, Russia, Western China, Thailand, Myanmar, Tibet, and a bunch of others that I couldn't even quite fit on this map. So because a place does not show up in your DNA, you can see here that little pieces of like Eastern areas over here do show up. There's a little bit of Russia that fits in here and over here, but the vast majority of it is not. So because an area doesn't show up in your DNA, might be that either that area does not have enough testable DNA yet, or it's an area where we can't really compare those biological profiles yet, whatever it is that makes it so that those areas do not show up on your DNA results. The point of all of this is that your DNA is probably not wrong, but the way that the company has interpreted it can be, and that may change drastically in the coming years. One of the other things that you can do if you feel like you're missing some things with your DNA is try taking another test. You're not likely to come back as 98% Spanish on one test and 1% on another, but the way that the companies break up their different regions and the way that they read your DNA can be a little bit different from company to company. So you might get some results on one test that answers some of the questions the other test gave you, and your truth probably lies somewhere in the middle of those. In a case of, no, seriously, I think they messed up my DNA and this does not belong to me, the first thing obviously you want to do is contact that company and make sure that you straighten that issue out like pronto, because that's pretty serious. Fun fact, about 99.9% of human DNA is identical. So it's just that last 0.1% that makes all the difference. Oops, I'm moving my... Okay, so we talked briefly about ranges. Ranges are run pretty much the way you would kind of expect them to be. They take your DNA and they compare it against the DNA profiles of people who are genetically ascribed to those regions, and they run those tests a few times. And so that's why you would end up with an ethnicity estimate of 57%, but can range from 57 to 77%. So I'm on the lower end, these are mine, on the lower end of that England, Wales, and Northwestern Europe. And you can see here, right there is that little bump that encompasses half or so of the Netherlands. And here's the border it shares with Germany. So Germany covers the other part. And here, my Irish and Scottish, 5%, my ethnicity estimate is 5, but it can range from 0 to 5. So I'm on the higher end of that scale. Since this infographic was done, they've actually rerun my DNA again. And I've now dropped to 37% England, Wales, and Northwestern Europe, and 22% of Scotland, because they split Scotland into its own region and were able to more accurately pinpoint to a region. As the pool of testable DNA grows, they will be able to be more and more accurate with who belongs where. These are our best kit awards. And unfortunately, we're going to have to kind of book because we've got about 10 slides left and only about 10 minutes left. So I got talking and got excited and lost track. But these are some of the ones, all of our PowerPoints are going to be up online, so you can certainly come back. Those of you who are on our Zoom call, you should have received the PDF for the PowerPoint in your email last night, so you already have a copy of this. My in-person people, you can go onto our website and download a copy of this, so you can sit and read the whole thing if you want to. Again, at the end of the day, your question really comes down to what is it you want to learn from your DNA? What is most important to you? History, accuracy, turnaround time, privacy, matches, etc. And what is it that you hope to accomplish? For African American ancestry, African ancestry, as we talked about, and the regular ancestry are the two that we recommend because of the numbers of regions that Ancestry offers versus most of the other places. For East Asian ancestry, most places recommend 23andMe and MyHeritage. For European roots, Living DNA is the one that wins out on that. They have about 810 separate regions in Europe. I did actually, because I did the research on who had the best, and then there were some, like for the African American roots we were talking about, I read articles on what they recommended for people who were specifically African American. Same thing for the Southern and Eastern Asian roots. I read articles on which ones, and I can, if you'd like some articles on that, I can certainly supply you with what I used to come to these conclusions. But I did the research and then compiled this list. And then for Native American ancestry, we get this one a lot as well. There's really not a test that's going to tell you where your family came from as far as Indigenous American people's testing. They unfortunately now make up such a small group of people that genetic testing is difficult to tie you to a specific tribe. And a lot of them have privacy concerns and stuff for that kind of thing as well. So the testing pool for that is particularly small. Also remember turnaround time for things like family trees, the 30-day average, that's going to vary widely depending on things like the pandemic, as well as their busyness levels. So right after Mother's Day or Christmas, when these kinds of tests are a hot gift, obviously that's going to slow things down. Other things to consider about your test before purchasing. Again, what is it that you want to learn? How much do you want to spend? How concerned are you about privacy? Do you want your health results? How long do you want to wait? Do you want to take the test with or for someone else? So are you buying a test for mom and you want to compare your DNA to mom's? It makes it a lot easier if you both take the same test. And do you want to be able to build a tree? Because not all software offers that option. Okay, so now we have gone over DNA, we have gone over testing, we have gone over the different tests. What does it all mean? Where do we go from here? Next, most people look to their matches, and so that's what we're going to do real quickly here. Most of these options have your matches for free or for an additional fee. Again, reading to make sure that you get that as part of your package is important. Also, most of them make you opt into getting matches. So if that's something you want, you need to read as you sign up and send your kid in to make sure that you get that option. Let's understand how these family connections work and what they look like. So what exactly are a centimorgan and a segment? What does a relationship probability mean? What is a second cousin and how do they get 3 times removed? What do these relationships tell me? What are some reasons I would contact my matches? And what can finding these matches do for my research? This is a table of consanguinity, which I will never be able to properly say as long as I live. It's also called a cousin chart, which is a lot easier to remember. Everybody should have gotten these in your packets. You should also have received a blank one that you can either pull up if you're on your computer, or you can kind of sit and look at and mentally fill out yourself as you sit here. Each step is a generation. So your parents are a step above you, your grandparents are 2, so on and so forth. As we said before, distance in your same generational line goes out and away, and your removal goes up and down. Cousin in your generation will share grandparents, a second cousin will share great-grandparents, a third great-great-grandparents, and so on. The most important part of this chart, though, that you really want to look at is your number of shared centimorgans. So when you start out with a parent, a biological parent, this is the only way that you can share 3,400 centimorgans with somebody else, barring some really weird genetic issues, is if that person is your child or your parent. That's the only way that's going to happen. Pretty much same with a sibling. A full sibling is about the only way you're going to get 2,500. From there on out, though, it starts to kind of get a little bit murkier. You're looking at 1,700 covers both an aunt and an uncle, a niece and a nephew, a grandchild, a grandparent, so on and so forth. By the time you get all the way down here to looking at about 13 point whatever centimorgans, you're looking at, I mean, this could be almost anybody on this line. Also remember that not every time are you going to hit these numbers. These are an average. But I, for instance, have a third cousin, and I know we're third cousins because we worked our tree up together, who actually has 111 centimorgans in common with me. We couldn't find anywhere where those lines would have crisscrossed, so the only explanation is just a fluke of DNA. We both just happen to inherit longer segments to share more centimorgans than the average. That happens in about 20% of cases. So it's not like super uncommon, but it's not common either. So if I'm just looking by my centimorgans, I might not have ever considered that she would be my third cousin. This is what the chart looks like when you fill it in. Okay, but the thing that I want to do, I got to remember I can't wander off. The thing that I want to look at here is really this line right here. So my cousin Jordan had his first daughter a year or two ago. Her name is Allie. Allie is not my second cousin. Allie would be my first cousin, one generation removed. She has gone down a generation from me. She's off of our generational line. My daughter, my theoretical daughter, and Allie would be first cousins. You have sibling, second cousin, I apologize. First cousin, Leela, and Allie, second cousin. So here we have my sister and my niece. This does not make her, a cousin or anything. Dropping down a generation only changes her relationship to my child, not to me. That's what you're looking at when you're trying to fill out your tables. How do these people fit together? Because figuring out where your matches fit on your family tree can really help you fill in some of those blanks. So how do I contact my matches? And better yet, why would I do that? One of the things that we're going to talk about contacting matches with is that a lot of people opt not to do their matches. And that's understandable because, again, you're dealing with spreading your DNA out into the public. There are other options if you don't want to go the route of seeing your genetic matches. Facebook groups are one of the big ways that you can connect with other genealogists. There's no guarantee that any of these people will be related to you, but most of the people in these groups are passionate about what they do as a hobby or as a job, and they will be happy to have another person join them and help them put together the pieces of their tree. These are the 5 biggest ones from Facebook. Facebook loves its Facebook groups. But there are other places you can go as well if you're not a big Facebook person. Altogether, they have over 11,000 separate genealogy groups on Facebook. So you can almost guarantee that you could find one that fits whatever you need. There are other options. Ancestry and WikiTree have message boards. For Ancestry, you do have to pay for a subscription to use the message boards, but you can read them for free. And then there are things like Twitter groups, Reddit, Pinterest groups, YouTube tutorials, social media in general. The list goes on and on of different ways that you can access help to continue building your tree if you don't want to share your genetic matches with anybody. There's also the tried and true routes of historical societies, periodicals and magazines, family history books, family search wikis. I mean, again, on and on and on. So if you're not comfortable sharing your genetics with anybody, there are other ways around it. Contacting on most of these are as easy as just hitting these little blue or gray buttons that talk about messaging somebody. MyHeritage also offers the option of connecting with your matches, but it's a little more complicated that I couldn't capture in a screenshot. Living DNA does not. Again, probably privacy rules. So mitochondrial and Y-DNA tests will not generally offer matches because their job is basically just to put you in a group. It does not genetically connect you to other people. Most of these sites, you, again, do have to opt in to receive both your matches and messages from your matches. So make sure that you're reading the fine print and you're okay with opting into receiving messages from other people. These are some of the great reasons to contact your matches. You have collaborated research, answers to questions you can't find elsewhere. You have brainstorming, finding missing members of the tree, exchanging of local resources. Somebody might have access to different repositories or libraries or history books that you don't have access to here. Photographs and memories, new and different regional information, and obviously you're building relationships with people who share your genetics. And contacting us. The reality of it is, at the end of the day, you got to remember, as I've said all along, your genetic DNA is just an outline. Your genetic DNA is not going to tell you everything about who you are or about who your ancestors were. Just because they don't show up in your genetic makeup does not make them any less a part of who you are. And you cannot tell an entire story. Wow, my voice is giving out on me. You cannot tell an entire story with just an outline. So you want to make sure that whatever you discover, you can back up with your genealogy. And that's where we come in. Here we are at the library on the second floor. You can call us or you can come in anytime. We are open anytime the library is open, except these hours. These are wrong because we're in COVID hours right now. But as long as the library is open, we are here except for 15 minutes before close. We have to shut the archives down. You can write us or you can visit us at EBRPL.com. I'm going to show you that one real quickly. So here is our website. And right down here is where you can find us. Here's your genealogy leaf. Classes offered. This is going to tell you what's coming up. Here we are today.
We can't see your screen.
And, oh, hang on. Thank you for letting me know. Let me switch my screen share. New share. Here we go. I forgot I had to do that now. Can you see us now? Can you see our library page now?
Yes.
Okay, good. Okay, so here's our front page of the library. You're going to come down to the genealogy leaves, up to classes offered, and then down to testing and results. Here's us today. Here's all of our upcoming classes. Here's information about the classes. And here are our classes on demand tab. So these are any other classes, and there's not wanting to load right now, but normally there's a video in this big blank space that you can watch. So if you can't make it to a particular class, but you're still interested in seeing it, those videos are always there for you to watch. Over here are our class guides. Download them, make notes on them, do whatever you want to do with them. Over here are some helpful links, census comparisons, group sheets, that kind of thing. Okay, so now we have, hey, I did pretty good. I was pretty close. Anybody have some questions you would like to answer or have answered? Yes, ma'am. Oh, I'm sorry. Yes, ma'am.
How long did you say the test results take
on average? It depends from company to company. She's asking how long test results take on average. The fastest turnaround time I saw was about 30 days. For Ancestry, it's usually 6 to 8 weeks. 23andMe is pretty similar. I think you can usually count on 1 to 2 months to be about the average. Some are faster, some are not. Yes, ma'am.
So for your maternal line,
Mm-hmm.
you think that living DNA or Ancestry would be?
Ancestry does not do your maternal mtDNA test.
That's right.
Yeah. But the ones that we see most often recommended, hang on, I'm going to switch everybody back. Hold on, my online guys. Oh. The one that I think would probably be best for that, there we go, would be yeah, MyHeritage does not, Family Tree does, and Living DNA does, and 23andMe does. I cannot tell you for sure which one is most well received for that.
Okay.
I did know, but now that you've asked that question, it's blown out of my head. She's asking which one is best for the mitochondrial DNA tests. But I know that those 3 of the 5 major ones do offer it. I can't remember which one is most well recommended at the moment.
Okay.
If you'd asked me an hour ago, I could have told you, but now that you put me on the spot, I can't remember. But those are really cool because they do go so far back. But like I said, the big drawback with them is that you don't, you know, it's an A to Z thing, but you don't get the rest of the alphabet in the middle.
Well,
Yeah.
You had said that the living DNA was the best for the mitochondria.
Is that what I said? Okay, good.
Okay.
There we go. Thank you. She says I told her my living DNA was the best for mitochondrial. So I knew I remembered. No, don't be sorry. I'm sorry that I blanked out.
No, I thought I wrote it down for sure, but I wanted to make sure that.
Yeah, living DNA is for sure the best as far as privacy goes. I believe it was living DNA.
But it doesn't have the help.
But it does not have the help.
You said that if a parent had taken a test to get the thing, the lineage, is best to take that test.
Yeah, generally, if you want to take it with a parent. So I got my parents, both theirs and my grandparents, and we all took the same one because it's a lot easier to compare from person to person because different companies test in different ways. your results might be a little bit off if you take, but you can certainly take 2 different tests. They're not going to come back so different that you're going to like completely miss it. But yeah, if you'd like to take it with somebody, it's always better to take the same test. All right. Anybody else have any other questions?
I just had kind of a comment. You were talking about like Facebook groups, along with the genealogy help groups. Like my grandfather's family, it's been in this country a long time, so there is actually a Facebook page for anybody with that last name, and then they help each other catch up, to connect, and you'll find some of those groups around.
Yeah, that's really cool. She was saying, for those of us in person who might not have been able to hear that, that her grandfather has been in this country for a really long time. So there's actually a Facebook page dedicated to that family, where various branches of the family can join that Facebook page and kind of catch up with where they are now and what's happening in the family. So that's another thing to look for. I didn't even think of that. So that's really cool.
Yeah, they go back to a tree that was built in the 1800s.
Wow.
And they recently have posted it, and you can find where your family connects to the
Oh,
tree.
that's cool. That's cool. So she said they actually have a tree that they've recently posted, so you can find where your family connects to that line. So yeah, that would definitely be something to look into as well, as you're looking into the origins of your name, and especially, you know, the origins of your name since you've come to this country. You might be able to find people that way too. And that way, even if you don't want to put your DNA out there and make connections with your actual matches, that's another way you can connect with family without having to worry about your privacy as much. I mean, as much as you can with dealing with Facebook, but
yeah, well, that's the trouble is Facebook has gotten so you don't want to deal with it like you used to.
Right.
So.
Oh, we have a patron asking, which family is that?
Lippincott.
Okay. All right. And if nobody else has any other questions, I hate to rush everybody out of here, but unfortunately I'm going to have to jump off of here so that they can get ready for the next one that starts at noon. And so
I have 2 questions.
I don't want to keep anybody, and I know we've actually almost gone over our time already because I talked too much.
Can I ask a couple of questions?
Absolutely.
You mentioned the variability that happens through the lines, especially, I guess, with siblings. Would you recommend that multiple siblings have the DNA testing in order to see, you know, what shows up for each one?
Yeah, it's really cool. My mom and her brother actually did DNA tests together, and his is significantly higher in a couple of places and hers is significantly higher in a couple of others. So, I mean, it's not really going to probably fill in a whole lot of blanks, because the example that I gave here was really, really extreme. And most of the time they're not going to be anywhere near this extreme an example, but you might find a couple of regions that you wouldn't have known about otherwise. So yeah, if your siblings are comfortable taking one with you, definitely.
Interesting. My other question was, what are the COVID hours?
Oh, our COVID hours, we're open 9 a.m. to 8 p.m. Monday to Thursday, and then 9 to 6 Friday and Saturday, and 2 to 6 Sunday. I do not know how much longer those will last, but I do know that we will probably be going back to our regular hours once they lift those restrictions.
One other comment. You have to also, if you're going to get into DNA and doing your tree, you've got to be willing to accept what results you get. I know a gentleman that he ran his DNA, and all of a sudden he has found some like half siblings that he didn't know existed because his father was all over the country.
Yes, and that's one thing that I meant to bring up and forgot to, but that's definitely something you want to take into consideration. You really, really don't know what might come back on your DNA. You really want to be prepared for any kind of surprises, because it has happened, and it really will upend families. So might be careful with that. All right, thank you guys so much. I hope that everybody enjoyed the class.
It was wonderful. Thank you.
Thank you. Thank you.
Yes. Thank you.
Bye.
Bye.
Bye-bye.